Ernest Rutherford was a scientist from New Zealand who was interested in knowing how the electrons are arranged within an atom. He designed an experiment for this. Now you can see the experiment setup. This is source of alpha particles. Alpha particles nothing but doubly positively charged particles, that is helium 2 plus. To see the deflection of alpha particles by thin gold foil, he chosen the luminescence screen. In this experiment, Rutherford observed few spots on luminescence screen. If J.J. Thomson model of an atom was true, Rutherford would have observed half of the alpha rays, that is doubly positively charged particles, would bounce back at an angle of 180 degree. As we already know, similar charge will repel each other, that is doubly positively charged particles would repel the positively charged proton, and the other half of the alpha rays will deviate from their path at some angle. It is due to the electrons, but that did not happen. But what he observed were most of the alpha particles passed through the foil. Some alpha particles were slightly deflected from their path. Very few alpha particles completely bounced back. From these observations, he concluded that the atom contains large empty space. There is a positively charged mass at the center of the atom known as nucleus. The size of the nucleus of an atom is very small compared to the size of an atom. The electrons revolve around the nucleus in a closed circular path called orbits. An atom as a whole electrically neutral, that is, number of protons and electrons in an atom are equal. So Rutherford's model of atomic structure is similar to the structure of solar system. Just as in the solar system, the sun is at the center and the planets revolve around it. Similarly, in an atom, the nucleus present at the center and the electrons revolve around its orbits or shells. According to electromagnetic theory, a moving electron should accelerate continuously lose energy. Due to loss of energy, path of electron may reduce and finally the electron should fall into the nucleus. If it happens so, atom becomes unstable, but atoms are stable. Thus, Rutherford model failed to explain the stability of an atom. Hope you understand the Rutherford's atomic model and its limitation. We'll see you in next video. Thank you. Bye.